Assalamualaikum, we are from Group 1, Class C EAC22227C4A, and today we would like to present about the evaluation and enhancement of road safety feature. So this is our overview of this project, and this is our team member. Our selected site location is located at Uitm, Shah near the engineering building and nearby the highway laboratory. So this is the problem identification based on our site selection. And this is the objective of skid resistance test.
So this is the apparatus for skid resistance test. This is the skid resistance tester, and we need brush and measurement.
So right now I would like to explain about the procedure of skid resistance. So for the first, we need to choose a place. For example, this rough surface, which is on the road surface lah. And the first thing first, after we have select the tested area, now we have to clear the area tested. We need to set the bubble level for the base, and we make sure that the bubble here is inside the boundaries, so that we can get the level flat. As we can see here, the bubble are in the boundaries, so we can start next procedure. Now we need to raise the pendulum so that we can swing it freely. Okay, after we have raised up the pendulum up, now we can see it can swing freely. As we can see, it can swing freely, and we have to calibrate this needle, and make sure the needle touch the zero. So,
as we can see here, after we swing it freely, we can see that this needle is not approximately to zero. So we need to calibrate it here to ensure this needle at 0 point.
whoa!
After we ensure that the needle is already calibrated to the zero value, now we need to place the measurement into the contact part, and we need to ensure that the point A to point B is between 10 to 12 cm.
After that, we need to lower down the pendulum arm until we get the rubber touch to the 3 points of the measurement.
As we can see here, the rubber only touched at the center of the measurement part. So, like you can see it. So right now, we need to lower down this pendulum to ensure that this rubber touched these 3 points.
So as we can see, the rubber have touched 3 points of the measurement of the contact surface.
Now the apparatus is ready, so we may start the experiment by pushing this button. Now we can see the data is shown here, and this experiment will be repeated 40 times to get the average reading.
Now, after we pour the water, we need to ensure that the rubber touch the wet area. Then we may take 3 datas.
Now we need to make sure that the rubber is wet with distilled water. Now the surface is already wet and the rubber is wet with distilled water, so we can begin the experiment now.
This is the data of time.
Take the data 3 times to get the average reading.
Result for skid resistance. Comparison with JKR specification. For the dry condition, the average skid resistance of 40.7mm meets the JKR specification as it is above the required 45mm. For the wet condition, the average skid resistance of 15.0mm does not meet the JKR specification as it is below the required, which is 25mm. Discussion for skid resistance. Comparison between dry and wet conditions. Skid resistance on a dry surface is approximately 2.7 times greater than on a wet surface. This stark difference highlights the reduced traction in the wet conditions, which increases the likelihood of slipping or losing control. For the skid resistance measurements, for the dry condition, the measurements across 3 trials are 42, 40 and 40mm with an average of 40.7mm. This indicates higher skid resistance on a dry surface. For the wet condition, the measurements are significantly lower, 10mm, 15mm and 20mm, averaging 15.0mm. The reduced skid resistance is consistent with the decreased friction caused by the water acting as a lubricant.
Hi and good morning. My name is Muhammad Zafar bin Sakti. Today I will show you on how to conduct sand-patch method test, which to evaluate the surface tension depth of a road surface. The objective of this experiment is to determine the surface tension depth by using the sand-patch method test, which is a very widely used technique to evaluate the bubble tension surface of the road. So this objective also to highlight the functionality of this test, which to ensure the stability and safety of the road user. So this is the apparatus needed to conduct this experiment. First we have ruler, dry sand, 2 types of brush, flat disc, measuring cylinder, 20 ml and funnel. After we locate the dry and clean section of a pavement, we need to use a brush to clean off any debris or soil on top of it. So for the second step of the procedure, first we need the resource leader, funnel and also the example of the dry sand. We need to measure exactly 25 ml of the sample of the dry sand to the axis leader. Next step of this procedure, by taking the 25 ml of measuring dry sand, pour it on top of the prepared surface of the paper. Next, by using the flat disc, use this to flatten the heap of the sand in a circular motion, moving counterclockwise or clockwise also. Okay, next, by using the ruler, or if you have any measuring tape, you can use it to record the diameter of the sand circle accurately. By using the brush, we need to clear off the used sand and leave the resting place in the original state.
In the sand patch test, the results were obtained by using a sampling sand volume of 25 cm3. The diameters were measured for 4 trials to get the average diameter of the sand circle. So, the average diameter that we get is 15.33 cm. As for the data and analysis, by using the previous average diameter that we get, the mean texture depth was determined. This value will indicate the roughness or the smoothness of the road surface. The mean texture depth calculation can use the formula as shown. Thus, the calculated mean texture depth we get is 1.35 mm. But according to the JKR specification, the required texture depth for sufficient skid resistance should be greater than 0.5 mm. The results of 1.35 mm that we get will comply with this standard, ensuring the surface meets safety and quality requirements for the road construction. Lastly, the discussion for this test, we identified that a larger sand patch diameter will indicate a smoother road surface with a lower texture depth. This implies reduced resistance and less effective contact between the tyres and the surface, which may affect water dispersion during wet condition. Other than that, a smaller diameter represents a rougher surface with higher texture depth, enhancing surface resistance and overall texture roughness. The calculated mean texture depth that we get meets the JKR specification and place the surface texture in the open category, signifying that it ensures adequate skid resistance and safety for road user.
This is the objective of outflow meter test.
So this is the apparatus for the surface drainage test. So this one is outflow meter, and then we also need stopwatch and also a water to fill up the outflow meter.
So for this surface drainage test, we need to conduct it at 3 different types of surface: smooth, medium rough and rough surface. So this is the smooth surface for our first test. So this is the outflow meter for surface drainage test. So firstly, we need to fill up the water until 300 ml. Okay. So for this test, firstly we need to open the valve at the same time we start the stopwatch. So right now we are conducting the second surface, which is rough medium surface. As for the procedure, just repeat the same step as the first surface. So right now we are conducting the surface drainage test at the third type of surface, which is rough surface. So for this test, we need to conduct it 3 times for one area. So for this smooth area, we need to conduct it 3 times and take the average.
And so now I will be discussing on the results, discussion and conclusion of outflow meter test. This is the results and data analysis for outflow meter test. The first one is for the surface texture of smooth, the average final time is 7.38 seconds, making the rate of flow is 4.07 times 10 to the power of negative 5 meter cube per second. As for the outflow meter test conducted on a medium rough surface, the average final time is 5.44 seconds, making the rate of flow is 5.51 times 10 to the power of negative 5 meter cube per second. Lastly, the average final time for outflow meter test on a rough surface texture is 4.7 seconds, and the rate of flow on this texture is 6.38 times 10 to the power of negative 5 meter cube per second. Next is the discussion for outflow meter test. For the smooth surface, the water took the longest time to flow out, which is 7.38 seconds, resulting in the lowest flow rate of 4.07 times 10 to the power of negative 5 meter cube per second. The smooth pavements drain water slowly, increasing water pooling rates. On highways, this can lead to hydroplaning and lower skid resistance in wet conditions. Smooth surfaces are unsuitable for areas with heavy rainfall. Next is the discussion on the medium surface. The medium surface has moderate pavement texture. The flow time is reduced to 5.44 seconds and the flow rate increased to 5.51 times 10 to the power of negative 5 meter cube per second. Medium surface also balances water drainage and ride comfort and drains water better than smooth surfaces, reducing water accumulation risk. and it is also maintain reasonable skid resistance and durability.
Lastly, for the rough surface discussion, rough surface represent highly textured pavement. Fastest water drainage is 4.7 seconds, and the highest flow rate is 6.38 times 10 to the power of -5 meter cube per second. To summarize, rough surface is ideal for highways in areas with heavy rainfall as it reduces hydroplaning risk and improves skid resistance. However, rough surface may decrease ride comfort and increase tire wear, and it should be used depends on specific conditions and requirements. So the practical implication in highway designs is first, durability, as good drainage prevent potholes, cracks and freeze-thaw damage. Second is surface texture because rough or medium texture improve pavement longevity. Third is comfort versus performance to balance roughness for drainage with smoothness for comfort based on road use. The fourth one is drainage, as textured surfaces like groving or open grated asphalt need to be used for effective water drainage. And lastly is safety, as textured pavement reduces hydroplaning and improve tire grip in wet condition.
Firstly, for the safety precaution, always wear proper PPE such as safety vest and safety shoes. Next, take measurement at eye level to avoid parallax area. Then, ensure the side surface is clean and free from debris to prevent accidents. Also, use calibrated equipment to guarantee accurate and reliable result. And lastly, place cones and warning sign to ensure control the environment and ensure safety.
Next, for the conclusion of skid resistant test, the dry skid resistant test meets safety standards, meanwhile, wet skid resistant test fails safety standards. This is due to human errors and need improvements. So the enhancements that can be made from this experiment is to improve the surface texture for better traction in wet conditions. For the sand patch test, it can be concluded that the texture meets JKR standards, which is MTD is equal to 1.35 mm. For these experiment enhancements, we can maintain or enhance texture for effective water drainage and skid resistance. So for the overall conclusion, we should focus on improving wet skid resistance, and texture for both safety and comfort should be balanced. Rough or medium surface texture should also be prioritized in high rainfall areas to minimize hydroplaning risk and ensure road safety.
This is our group references, which include all the sources we use for this project. That is all from us, Group 1 CEEC 2227C4A. Thank you for your attention.